2211 Lab V by Nguyen. The introduction. The purpose of part 1 is to determine the mass of a black hole by tracking and analyzing the motion of a star. And for the part 2 is to determine the initial velocity of the ship leaving the planet to escape the black hole. The main concepts of this experiment is gravitational force and non-constant force. The main method of this experiment was to use glow script coding to find the change of position of the star and use those values to find the average mass of the black hole. The net force was then calculated to determine the ship's initial velocity. The main result of this experiment was that the mass of the black hole was 1.41374 e to the 34 kilograms, and initial velocity is negative 10 to the power 7 and 10 to the power 7, 0 meters per second. A non-constant force is applied to an object when the net force acting upon that object is changing. Example is gravitational force. And for the formula for the universal gravitation is G times mass 1 times mass 2 divided by r squared times negative r hat. Now, for non-constant forces, the kinematics equation is different. Vf equals Vi plus F divided by m times t, and Rf is R1 plus Vf times t. The system for part 1 is the star, and the system for part 2 is the ship and the planet. The surroundings for both parts is the black hole. Initial conditions, we assume that delta t, which is 1 day, is 86,400 seconds, and that Vs is negative 10 to the power 7, and Vy is 10 to the power 7. Now, we assume that there are no additional forces such as static or friction or acting upon the system except for the ship, black hole, star, and planet. For part 1 of the experiment, we had to substitute the gravitational constant, the mass of the star, and the delta t. Now, we would then find the momentum of the initial and the final, which as you can see in this code, and you have to find the delta v and the delta p, which is delta velocity and delta momentum. Now, you would find the dp divided by dt by dividing the delta p momentum divided by delta t. Now, using that, you would calculate the net force, and then you calculate the force of the parallel to the system. Now, to find the force of the perpendicular, you would subtract the F net minus F parallel. Now, once you have that, you can calculate the mass of the black hole. And as you can see on the right, that is the motion of the black hole around the sun. Now, for part 2, we use the mass of the black hole we found from part 1, and then you would plug in your other constants such as gravity, mass, and the mass of the ship, and you would calculate the planet's speed and velocity, as well as the ship velocity. And then once you have that, you would have to calculate all the stuff you see on the right. And you do that, and you would find the initial velocity of the ship. As you see on the right, this is the motion of the ship around the black hole. Now, main results from part 1 is that the F net was 9.36145 e to the power 28 newtons, but the main mass of the black hole is 1.41374 e to the 34 kilograms. Part 2, that the ship is 5.12565 e to the 10 meters away from the black hole. So our narrow analysis is that there were large time steps in this coding experiment, and there were inconsistent masses of the black hole, which we had to find the average to calculate the average mass. Now, what if we wanted to peak inside the black hole, but we needed a new velocity? So the new initial velocity would be 3.4 times 10 to the power 6, and then 11.2 times 10 to the power 6. The x component would need to be smaller to avoid being sucked into the black hole, but the y component also need to be larger so that it can follow a similar path around the black hole. Now, the parallel and perpendicular force components. The force of the parallel and force of the perpendicular is equal to the force net. Force parallel is dmagp divided by dt times p hat, which is just a parallel to the direction of motion. Now, the force of perpendicular, to find out, you just subtract the F net minus F parallel. And this is all the rate of change of momentum, which is dp divided by dt. Conclusion. For part 1, the average mass of the black hole is 1.41 e to the 34 kilograms. Part 2, the initial velocity of the ship was negative 10 to the power 7, 10 to the power 7, 0 meters per second. Thank you.